Okay, so in this question, we are asked to determine the difference in pressure between points A and B. And you can see that through this whole pipeline or whatever, we have different fluids. So if you want an order of operations for this kind of question, the first thing I would suggest doing is identifying a reference point. So typically they'll give you your heights, so these are all your different heights, and they'll give you it with reference to some reference line, if that makes sense. So you can see this line over here runs consistently, right? So we can use that as a reference line. Okay, so the pressure here, we're going to call that P1. Pressure there, we're going to call that 2. Okay, and then as you're labeling your pressures, kind of follow the pipe as well, right? So we're going down to P1, then up to P2, then wherever you see a change in fluid, then we're going to label that as a different pressure, right? So we're going to call this P3. We're going to go up, we have a change in fluid over here, so we're going to call that P4. Going to go down, we reach our reference line again, so we're going to call that P5. Then we're going to go around, we reach our reference line again, we're going to call that P6. Going to go up, we have a change in fluid, P7, and then at the end over here we can call that P8, or we can call that PB, right? So it's basically in line with B, so that's the pressure at B. And similarly, this point here is PA, it's in line with the point A, right? So we can call that A, we can call that B. Cool. So we want to determine the difference between the difference in pressure between points A and B, right? And this would be a pretty easy problem if there was a uniform fluid throughout, right? So the difference in pressure, if the fluid was uniform, let's say point A was here and point B was down here somewhere, the difference in pressure if the fluid was uniform would just be, so let's call this the heights, the difference in pressure would just be rho times G times H, right? And then the rho would be the density of that specific fluid. But because there's so many different fluids throughout, which density do you choose, right? And the answer is that you can't really choose a single density because it's not the same fluid throughout. So for example, the pressure at point 1 over here is the beginning of mercury, and that won't necessarily be the same as the pressure of the water over here because of the different densities. At least that's what I understand it to be. Might be wrong in saying that, but yeah, essentially with this question you can't take that shortcut of finding the difference in height between A and B and then just saying the difference in pressure is rho GH. You have to kind of work through the whole system, right? So what we're going to do is we're going to calculate the pressure throughout, right? So we're going to start at point A, then we're going to move down, calculate the pressure at point 1, right? Then we're going to move across, calculate the pressure at point 2, then to 3, then to 4, then to 5, so on and so forth, right? So yeah, so let's start with the pressure at point 1, since we're going to define PA as PA, right? So PA right now is not known, which is fine. We're not looking for PA, we're looking at the difference, looking for the difference in pressure between A and B, right? So let's jump to P1. So P1 will be equal to the pressure at A plus the density, so rho of benzene times G times the height difference between 1 and A. Okay, so we could even call this delta H 1A, right? Okay, and then because we're decreasing, as you decrease, pressure increases, right? So we're gonna define a decrease in height as positive. So decrease in height is positive, and then increase in height will be negative. Reason why we do this is because as you decrease, your pressure increases, right? And then as you go up, right, your pressure decreases. So the pressure at this point over here will be less than the pressure at point 2, for example, right? So yeah, hope that kind of makes sense. So we are increasing, so that's why there's that plus sign, as we go from point A to point 1, right? So the pressure at 1 is just VA plus rho of benzene times G times the height, which is 0.2 meters, right? Cool. Then P1 will be equal to P2, okay? Reason being is because it's the same fluid, so we have mercury at this point over here, okay? And it's at the same height, I guess. So the pressure at 1 will be equal to the pressure at 2, okay? So because of the same height kind of thing. Hopefully that makes sense. And then we want to move from 2 to 3, and we're going up, so we're going to subtract, so our height will become negative. So we have P3, we want to calculate P3 now. So we have P1, we have an expression for P1, and we said this expression for P1 is equal to P2. Okay, so we have equations for P1, P2, now we need an equation for P3. So P3 will just be equal to P2 minus the rho of mercury times G times the height, which is 0.08. So it's negative because we're moving up from point 2 to point 3, so it's going to be negative. Yeah, and that's basically it. And then we can substitute this equation for P2, then the expression for P3 becomes PA plus rho of benzene times G times 0.2, right? So that's the P2 part of the equation. Now for that part, so it's going to be minus rho Hg times G times 0.08, right? So it's pretty simple. I guess the steps to it are the next point that you want to calculate, which is going to be 4. So you always look at your next point that you want to calculate for, and then it's either going to be the previous pressure plus or minus rho G H to the next point, right? So we want to calculate for P4 now, which is going to equal to the pressure at our previous point, which is 0.3, and then it's either going to be plus or minus rho GH, and the height will be from 3 to 4, so from the previous point to 2.4. So we're going up, so it's negative, and then the density of kerosene, so rho K rho k times g times the height from point 3 to point 4, which is going to be 0.32 meters. Okay, and you pretty much work your way throughout kind of like that. So you're going to do 0.4 to 0.5, then 0.5 to 0.6, 0.6 to 0.7, and 0.7 to point B. Yeah, so you just carry on working like that, and then you're going to get a final expression which is going to state PB is equal to PA something 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 something, right? Cool. Then all you're going to do is you're going to bring your PA to that side of the equation, so you're going to get PB minus PA is equal to all your different terms. Cool. Then the question asks for the difference between points A and B. So this is the difference between B and A. So we want A in front, or we want A to be positive. So we're just going to multiply by a negative. So we're going to get PA minus PB is equal to negative something something something. Okay. I hope that kind of makes sense.